Hi everyone, and welcome to a Tarkeeb session by the Assembly in association with Future Now and In5. We're very glad to see you here, and we're going to be covering a very interesting topic today with a great presenter who has a lot of experience in the field. Before I introduce him and I introduce the topic, we're going to go over a little bit about the Assembly for those of you who are not familiar with us. Okay, I'm just going to bring up my slides. So, as I said, the Assembly is a smart lab and makerspace that's based out of In5 since 2014. In5, of course, is the technology and innovation hub for Dubai Internet City, and it's a home to many different startups who work from this space. And alongside these startups, we have our own smart lab where we do a lot of interesting things. One of these things is that we have been doing right from the very start is presenting free community workshops to teach people about technology and give them exposure to exponential technology in a collaborative way. We've done over 300 free workshops since the start of our time, and these workshops have been categorized into a few different streams, as we say. The first, of course, is Assembly hack workshops, which could be related to embedded systems and IoT and hardware. So these are workshops where we might be working with Raspberry Pis, Arduinos, sensors, different kinds of electronics that are still programmable, of course. But when you come for these sessions, you don't need to bring your own hardware. We will provide all that for you. You just need to bring your laptop and we'll show you how to work with that. Assembly code sessions, as opposed to Assembly hack sessions, focus on software and APIs and frameworks and apps. So you don't need any separate hardware for that. You can just bring your laptop. Well, your laptop is the only bit of hardware that you need to bring for that, and we show you how to work with with programming, all different types of platforms in that. We've separated out Assembly data science as a separate topic out of Assembly code because we found a lot of our workshops cover artificial intelligence and machine learning, and we decided to make that a separate stream so that we can definitely focus on that and present it in a different way. Our audience ranges from all ages and all sorts of background. Obviously, we're in an entrepreneurship hub, so we see a lot of entrepreneurs, but we also see a lot of working professionals and students as well, and anyone who is interested in technology and interested in doing more with technology is welcome here. So there is no bar, like I said, about age or experience levels. We try to cater to everyone and we try to bring them together so that they can interact with each other as well. Our focus is obviously on smart technology, but also on the practical applications of smart technology. We don't want to only give you 101 sessions where you just go away with a bit of theory. We want you to actually build something, whether it's hardware or software. Our social media is actually our mission statement as well, make smart things. So you can find us at Make Smart Things on Facebook, on Twitter, on Instagram, and LinkedIn, as well as on YouTube, where you will find us. You'll find a lot of videos of smart things that we have done. We've also uploaded a lot of these workshops that we've done online, especially in the past couple of years, to the Assembly website, and you can definitely check those out. But our live sessions are now back in full sway, and we are going to be doing these regularly at In5. So please do come across and check us out at In5. We have as our own social media forum also at members.theassembly.ae if you'd like to interact more with fellow members of the community. Now, I'm going to get straight into our workshop. Like I mentioned, we have a very special guest presenter. As most of you know already, today's workshop is going to be an introduction to 3D game development using the Unity platform. And for this workshop, we have our special guest presenter, Mustafa, who is going to be joining us. And before I hand over to Mustafa, I wanted to do a little bit of an introduction so that we can definitely let you know what you can expect in this session. Mustafa is a game developer, a game engine programmer, so that means that he's worked right at the core level of gaming also, as well as a full stack developer. So he's not just focused on gaming, he's also worked a lot with full stack technologies, and he's also a gaming instructor. So he definitely has been able to teach a lot of people how to get into this. So he's the ideal person to show you how to get started with things like Unity. Unity, of course, is the platform we're working with right now, but Mustafa has 10 years plus dev experience with not just Unity, but also with OpenGL, DirectX, ARCore, Vive VR, so augmented reality as well as other gaming platforms. But like I mentioned, he's a full stack developer, so he's also worked with React and Node.js and other JavaScript platforms, as well as Android and iOS apps and many other platforms. So he's an all-rounder when it comes to development, and that really helps when you're good at one type of development, you can definitely do other types. So Mustafa launched his independent gaming studio and software development house called Blue Monocle Software in 2019, and you can find out a little bit more about Blue Monocle at the site. You can definitely see the kind of things he's been working at. And in that time, he's also continued teaching gaming to people at the SAE Institute as a guest lecturer. In specific, I'm going to let Mustafa tell you a little bit more later on, but he's developed and published 2 gaming engines as well, including his own called Blue Flame using C++, OpenGL, and DirectX. And he's published multiple games, both as himself as well as under the Blue Monocle banner, and is currently leading work on a next generation MMORPG game using Unreal Engine 4, which I'm sure he'll tell you a little bit more about. You can find out a little bit more about Mustafa's portfolio at m-sibai.com, so do check that out. And without further ado, now let me introduce you to Mustafa. Mustafa, please take it away.
Thank you, Nikhil. Hi, everyone. Today we're going to start with creating the project in the Unity engine. The version of Unity engine we're going to use is the 2020.3.31 F1. So this is the latest 2020 version from Unity. This is what is called the LTS version, or the long-term support version. The long-term support version essentially has the least amount of bugs, and it doesn't have the latest and greatest features from Unity. However, it is the most stable version with the least amount of bugs and the least amount of crashes. So this is the version we're going to be using today. Any version moving forward should work pretty much exactly the same. Unity really hasn't changed much in the past 3 years in terms of the major API and major structure for the engine. However, there have definitely been new features added to the engine since then. So today what we're going to create is a top-down shooter game. We'll start with implementing the first-person shooter game, and then take it try the top-down perspective from there. All right, so this is what is called the Unity Hub. And Unity Hub essentially is an application that manages all the Unity versions that exist out there. So you can install multiple versions like 2020, 2019, 2021, and so on and so forth. And so we are going to create our project from this application. The version of Visual Studio we're using is the Visual Studio 2022. You could use 2017, 2019, they both work just fine. However, 2022 has the latest and greatest features, and it's a lot faster than previous Visual Studio applications. We need Visual Studio in order for us to start programming and actually write some code. As you know, Unity uses the C# programming language, and so we're getting this Visual Studio to do that. So we really need both applications to get started in the engine. After you've installed Unity Hub and installed the 2020.3.31 F1 version, you can go to Projects, click on New Project. And from here, you can see there are multiple templates and multiple options on how to start your project. There's a 2D version, 3D, AR, VR, third person, and a bunch of other templates. There's even the Lego micro game in there, which kind of gives you an entire full Lego game and shows you how that is essentially built up. For our needs, we're going to just create a bare bones 3D template, which will have essentially nothing. On the right side, we're going to name our project. So I'm going to call this 3D top-down shooter. And so I'm going to click on Create Project, and that will take a few seconds in order for Unity to initialize the project and start it up. Once Unity opens up, you'll be presented with an interface that looks something like this. So what I'm going to do is explain each part individually, and we'll start with the scene window. And this is the scene window. The scene window essentially is where you're going to build your level, where you're going to place your characters, your enemies, your buildings, the water, essentially the entire level of the game. So you'll be working in this window a lot. The next window you're going to see is the one on the left, which is this part. This is called your hierarchy. Essentially, the hierarchy is the window that contains all of your game objects. Everything in the world is a game object, whether it's a tree, a car, the player, enemies, weapons, everything really in the world is a game object. Game objects on their own, they're completely useless. They're only a container. They only contain components. Components are the things that define the logic and define the behavior of how a game object should behave. So you can think of a game object as a box that has components, and these components define what this game object does. As an example, you can have a car as a game object. However, the car on its own will not be able to move forward or turn right or left or go backwards. And components essentially tell the car how to move and how to behave in the world. So you can have a component that tells the car to move forward, a component that tells the car to go backwards, a component that lights up the headlights in the car, and so on and so forth. So essentially, components are the behavior of the car. So in the hierarchy window, you will see all of your game objects. As you can see right now, there are two game objects that exist, the main camera and the directional light. If you look on the right side, this is called the inspector window. Now, the inspector window is the window that contains all of your components. And as you can see, for example, the main camera has three components currently. It has the transform component, the camera component, and something called an audio listener component. Now, these components define the behavior of the main camera. If I click on the directional light game object, you will see that that game object has two components, the transform component and the light component. You might have noticed that both game objects have one component in common, which is the transform component. Essentially, the minimum amount of components a game object will have is one, and that's the transform component. So every game object in the world will have at least the transform component. And the transform component defines things like where it is located in the world, the position of it, what is its rotation, which direction is it facing, and the scale, how big or small it is. All right. Next up, I'm going to talk about the bottom window, which is called the project window. Now, the project window is the window that contains all of your assets like textures, music, sound effects, 3D models, anything really you need to build up your game will exist in the project window. Next up, we'll have the console. The console window will give you information about your game in form of messages, text, readable, human readable messages. There are three types of messages. There's information messages, there's warning messages, and there's error messages. And so, for example, if you have an error in your game, it will be presented as a red error message. And essentially, that's the most dangerous message. You have to fix it immediately or try to fix it. Otherwise, your game is not going to function correctly. A warning message is, it's preferable to fix it. However, if you don't fix it, nothing really will happen. A information message just tells you what is going on in the game. So for example, you might have an information message as I connected to a server, or you could print the player position as an information message, and so on and so forth. So the console is really, really important when it comes to kind of what is going on in the game. Finally, the last window I want to talk about is the game window. It is right up next to the scene window. Now, the game window is the window that you're going to play your game and test your game in. As you can see here at the top, there's the play button and there's a pause button. The play button, you're going to press that when you want to start testing the game and actually play the game and see how it works. And you will be able to see the game and play the game in the game window. Essentially, the game window is what your players are going to see when they play the game. The pause button will pause the game. And that is essentially really it. That is the entire interface, or all the major windows inside of Unity. What I'm going to do is I'm going to change the layout a little bit to fit kind of my needs. What I essentially like to do is to take the console window and drag it and put it on the side, to the right side. The way you do that is by clicking on the window, click and hold, and move to the right. And you will see it kind of looks like this, and you dock it. So now my console is side by side to my project. I like to do the same thing with my game window. So I'll drag my game window, kind of dock it on the right side. I kind of use this line to make the window either bigger or smaller. So I'll put it somewhere in the middle. So I'll resize my interface a little bit. It looks something like this. All right, so we'll jump in and start doing some stuff. So how about we create a cube in the world? So what I'm going to do is right-click in the hierarchy, go to 3D objects, and create a cube. What that will do is it will create a cube somewhere in the world. It will give you the option to rename the cube. So if I want to rename it, I could. So for example, I can call it box. And if you click on it, you can see all the components that exist on the right side. So you can see you have your transform component, your mesh filter component, mesh renderer component, and box collider component. Don't worry about these components too much right now. We'll go a lot more in depth later on. The really important part that I have to emphasize for everyone who's using the Unity engine, or anyone that creates really a game object, it is extremely important once you create the game object, you reset the transform. You could either set the values manually, like clicking on the position for the x-axis 0, 0, 0, and rotation 0, 0, 0, and the scale 1, 1, 1. You can either do that manually, or you can click on the 3 dots over here at the top right of every component. Every component will have these 3 dots at the very top. When you click on it, you can click on reset. What that will do is we'll reset the game object in the center of the world. Now, why is that important? Well, essentially, you want to have all of your objects kind of in the center of the world. That will become an issue later on when we're doing the parent and child relationship. I will show you that in a second. But essentially, I have my cube. It's in the center of the world, and I can look at it. Now, to move in the world, what you do is you right-click with your mouse button, and you kind of look around in the world. Move your mouse right and left. While holding right-click with your mouse, you can press WASD to move in the world, just like a normal first-person shooter. If you want to move faster, you can hold Shift to move a bit faster. And that's essentially are the controls of Unity. They're really, really easy and very intuitive. If you've played any games before, that shouldn't be an issue for you. Now, to move objects in the world, you can click on them. Let me rotate the camera in the correct direction. Essentially, the correct direction would be the Z-axis pointing forward, the X-axis pointing right, and the Y-axis pointing up. So the X-axis, or the red arrow, essentially that's the direction of right and left. The forward and backward direction is the Z-axis, which is the blue color, which is the blue arrow. Now the yellow or green arrow is the up and down axis. So I can click on any of these arrows to change the movement of my cube. So if I click and hold on the blue arrow, I can move forward and backwards. If I click on the red arrow, I can move right and left, and I can only move right and left. If I click on up, I can only go up and down. So I can use all these 3 arrows to move my object a little bit better. Now, there's also a way you can move the object if you click on the center. And if you look a little bit, if you zoom in a little bit here, right? What essentially you could do is move an object in 2 axes at the same time. So if I click on this kind of plate over here, I can move my box right, left, up, and down. If I click on this plate, I can move forward and up and down. If I click on this one, I can move right, left, and up and down, and forward and backwards. I highly recommend you don't do it that way. I highly recommend you use the arrows. And the reason I say that is because right now we're in perspective mode. Essentially, perspective mode means that objects that are further away in the world, they're extremely small, just like in real life. If you have a plane far away is small, and a plane that close to you is really large. And so essentially perspective mode does that. And because of perspective mode, you won't be able to tell where the cube is, whether you move the cube a little bit to the right or a little bit forward or backwards, right? It'll be a little bit harder to deal with. So I highly recommend you always move with the arrows. All right, so I have a cube, and what I'm going to try to do is build a house out of the cube. So I'm going to start by building the walls. I'm going to make my cube a little bit larger and make a wall like this. I can duplicate this object by pressing Ctrl D. So that'll create a duplicate. And then I can press Ctrl D again to make another duplicate. Rotate this on the y-axis by 90 degrees. And then duplicate that again. And then duplicate that one more time. Rotate this on the x-axis. Rotate this on the z-axis by around 45 degrees, something like this. And you could duplicate that one more time. So essentially, we have a house of something like this. And that's really awesome. We built the house at the origin. And at the origin means that we built the house in the middle of the world. Now, if I want to move the house somewhere else in the world, well, I would have to move every object individually, which is really, really annoying and it's not very good. Essentially, you're tearing the house down and building it over somewhere else. The other way is you could select all of the game objects. You can click Shift and select all of them and kind of move the entire house. But that's also tedious and not super great. Now, what Unity offers you is a parent and a child relationship. So essentially what I could do is create a parent, and all of these game objects will be a child of that parent. So if I move the parent, all the children will also move with it. If I scale the parent, all the children will scale with it. Another way to do that is you can create any type of game object, whether it's a cube, a sphere, capsule, a light, really any type of game object. But in our case, we don't need any components for our game object, right? We just need the transform component. So what I can do is create an empty game object and I can call it house. Make sure again, you reset the transform of the house and then select all of these game objects and drag them as a child of the house. And you can see all of these are indented a little bit to the right. Now this is my house. I can move my house anywhere that I like. Now let's assume you've forgotten to reset the transform of the game object. So I'm going to Control Z a couple of times. And you can see that my house is currently, when I created the game object, the house is essentially over there. Right? This is, you will not be able to see it, right? An empty game object, when you create an empty game object, you only have a transform component. You don't have anything else. So in the world, nothing will appear. So let's assume I forgot to reset my transform. And I'm going to take all of these and put them as a child of the house. You'll notice that if I change this a little slightly, so if I change, I have to press this button, so I have to go from center to pivot. So you'll notice that right now, in order for me to move the house, the pivot is all the way to the right, or all the way up there. It is no longer in the middle of the world. And so if I reset the transform now, that transform will be in the middle of the world. However, the house is on the bottom left, which is not great. And that's why I will say, make sure to always reset the transform. So if I reset the transform right now, you'll see that the transform is currently sitting over here. And I can take all these parts and put them as a child of the house. So now if I click on the house, you'll notice where the pivot point or where the game object exists. So I can move it, it'll move the house essentially with it. Now we can modify the pivot point a little bit. Maybe you want it a little bit in the center. So you can move the game object a little bit like this. And now attach everything to the house. So now the pivot point is kind of in the center of the house. And so that is really important. So I can reset everything to 0, 0, and you can see the house, or the middle of the house is now in 0, 0. So essentially, resetting the transform or playing with the transform position with the parent and child relationship allows you to figure out where do you want the pivot point of your model or your object. That is really all. All right. So the next part I want to talk about is materials, how to create materials. Materials, essentially, they allow you to change the color of a game object or allows you to change what is called a texture. If you don't know what a texture is, essentially it's just a 2D image that you slap on a 3D object or wrap around a 3D object. And I'll show you how that looks later on. But a material essentially allows you to add textures. It allows you to change the color of the object. It allows you to define the behavior of the light, how the light interacts with your game object. So for example, you could create a material that is more wooden material where the light will not reflect as much. Or you could create a metallic material where it's very glossy and the light will reflect and it'll be very shiny and it'll look pretty cool. So the way you create materials is you can go in the project area. I like to be organized with my project, so always make sure to create a folder for things and keep things organized generally. I'm going to create a folder called materials. In my materials folder, I'm going to go right click, create material, and call this red. Now, obviously, you don't have to create the folder. You can just create the material anywhere you want. But like I said, I'd like to keep your project as organized as possible. So I named my material red, and it looks like a sphere, right? And you can see a preview window of how that material looks like on the right side. And what I want to do right now, there are a lot of options here. It will be a little bit overwhelming. Essentially, the only thing that I really want to change is the color of my material. Currently, my material is white. So you can see here the white color. You can click on it and change it to red. And you can see it will be reflected in the preview window. And you will also see the red material over here. What I can do now is grab the red material and attach it on the house. And so you simply click and drag the material to the game object and it will paint it that color. Now we have a red house, which is pretty cool. If I create another material, let's say call it blue, and give it a blue color, now I can make the roof blue and the walls red. Looks like a nice house. So that's how you create materials and that's how you assign them. Now the next thing I want to do is save my scene. If you don't know what a scene is, essentially a scene represents a single level. So one scene represents a level. So I'm gonna save my scene by pressing Ctrl S. Now you will know that the scene has been saved or the scene has not been saved is if you look at the very top right, you will see there's a star. It's very hard to see. Let me magnify that for you. So if you look at the top here, you can see there's a star over here. Once you save your project by pressing Ctrl S or by going to File and Save, you can see the shortcut is Ctrl S. That star will disappear. So I'm gonna press Ctrl S right now. You can see the star is gone. So make sure you're always saving your scene, because if you forget to save your scene, essentially your level is all gonna disappear. All right, so we went over how to move in the world, how to create something in the world, how to attach materials and the interface and all the components and game objects in Unity. What I would like to do is talk about the prefab system in Unity. It is really important and it's an essential part of the Unity engine. To demonstrate the prefab system, what I'm going to do is duplicate my house, duplicate 4 houses, and then I'm going to duplicate those. And then I'm going to duplicate those to make as many houses as possible. All the houses. All right, so I have a bunch of houses, a lot of houses. And so let's say you're building your level and you've decided one day to change the color of the houses. And now you thought blue is not great. We want to change it to green. So you go ahead, you make a new material called green, and you assign the green color. Now you go ahead and start changing the color of every single roof. You can see it is extremely tedious. It will take a long time, and it's not the greatest way of doing things. So what we can do instead, before we've duplicated our houses, if I Control Z all the way to when I had a single house, what I can do is essentially create what is called a prefab of this house. A prefab essentially is taking a game object and saving it as a file. So I'm going to create a new folder, call it Prefabs. And in this prefab folder, I'm going to drag my house inside the folder. And that's my house. It is now a prefab. And notice what happened when I did that. When I created my prefab, the actual icon turned blue. So if I Control Z to go back before it was a prefab, you can see it's a normal gray color. When I dragged the game object to my project area and put it over here and create my house, it is now a blue color. And so the blue cube indicates, and the blue text indicates that this is a prefab. Let me delete the prefabs that I already have that existed. I'm going to right click on the object, go to prefab and unpack completely. Essentially that breaks the link between the game object and the actual file. Since I deleted the file, I'm going to create it one more time by just clicking and dragging it in the area, and that creates my prefab. So now I have a prefab in the world. So now if I duplicate this, duplicate this, and go. Duplicate all of these. My neighborhood or my houses are not very aligned, but that's okay. Anyways, I have a bunch of houses. And now the really cool thing is if I would like to change one of the houses, I can go into the prefab file itself and I'll change the material from blue to green. So click on that, drag that over. And when you open a prefab folder, when you open a prefab file and you look in the world, your entire level disappears because a single prefab contains a single thing, or what that prefab contains, right? And in our case, our house prefab only contains our house. So we'll kind of see this blue area where only our prefab exists, and we can modify our prefab. So if I click on the back button over here in the hierarchy window, you can see all my houses now turn to green. Now the reason that happened is because every single prefab is linked to my file. And so if I change my single file, all of these prefab will also change. And that's really the cool system about prefabs, and that's really the cool part about them. And so now I can just delete all these game objects and I have a single greenhouse, which is cool. Now, prefabs are also used for the spawning system. If you ever want to spawn something in the world, you really don't want to have that in the hierarchy. So for example, if you have an enemy, you don't want to put the enemy in the hierarchy because it will show up in the game. So you want to delete everything. You don't want to have any enemies, and then spawn the enemies using a prefab. So I'll just drag this and put it in the world. Now I'm doing that manually, but when you actually spawn it, we're going to do that in code. So prefabs are very useful to be able to do something like that. All right. So far we've created the house. It looks very cool. We can move in the world. You know how the interface works for the most part. The last thing that I want to talk about before we move on to importing 3D models and kind of setting up the game is to talk a little bit about the top buttons over here in the interface, which I haven't really covered at all. So I have my house. I'm going to reset the transform of my house. Kind of be in the center of the world or the origin of the world. I'm going to zoom a little bit here. So if I click on my house, you can see that I can use these arrows to move the house in the world. And so the way I do that is by clicking on this move tool. So if you have the move tool selected, you can move in the world. If you the next tool next to it is the rotation tool or the rotate tool. If you click on that, you'll be able to rotate the house in any direction you like so. Next up is the scale tool, which will allow you to scale the house in any direction you want. So you can scale the house like this, like that, like that. If you want to scale the house uniformly in all directions, you can click in the middle, you can scale it in the middle. The next tool is, don't worry about this tool. It deals with the UI interface or the user interface in the Unity engine when we build user interfaces. So it's not going to be very helpful right now. The last tool that I want to talk about is this one. Essentially, it combines the position tool or the move tool, the rotation tool, and the scale tool all in one. So you can see I can scale my house, I can move it, I can rotate it, and so on and so forth, which is pretty cool. So, and before I forget, there's also the hand tool where you can move in the scene by clicking and dragging, but it's not really common, or I don't use it that much. Really, the most useful tool that I use is the move, rotate, and scale. All right, so now that we've I'm gonna reset the transform. Now that we've kind of covered most of the interface, or all the interface in Unity, what I want to do is kind of start importing 3D models and because we have cubes, they look nice and all, but we would like to have some animations and actual 3D models. So go to your favorite web browser and type Adobe Maximo or Maximo. So you can click on the first link. Make sure you created a new account. It's free. If you already have one, you can simply log in. Once you log in, you'll be presented to the screen. The first thing you will see is the character tab. And the character tab essentially allows you to pick whatever character you want. So for example, if I want this character, I can click on him, and in a second, you'll see that he'll be presented on the screen like so. And we call this as a T-pose because it looks like a T. And so if I want any other character, for example, the mutant, I can click on him and select him, and he'll be presented over here in a few seconds. All right, so here's our mutant. You can see it looks like that, right? For now, this is kind of the model that I want, and I'm gonna select. For animation, you can add any animation you want for any 3D model you want. So if I click on the animation tab, you'll see that if I select any of these animations, they'll be applied to our 3D model. I'm going to select this one. You can see now he's playing that animation. If I select this one, you can see he'll play that animation, and so on and so forth. There are animations specific to him, and there are animations that for other characters. And like I said, any animation really works. One issue though is that you'll see that this character has an actual axe in his hand. I'll give you a better example. You'll see that this character has the sword in her hand. And so if I apply this animation to my mutant, he's not going to get the sword, but he's going to get that animation. So it's up to you to go and attach a sword in his hand to be able to actually look like that. But the animation will actually play like so. Now you have a bunch of options on the right. Whenever you pick an animation, you have a bunch of options on the right. For example, overdrive will allow you to speed up the animation, like so, or slow it down, like so. You also have the options of arm spacing. So 50% is the normal rate. For arm spacing, I can either make my arms spacing lower. So you can see at this point, his arms are kind of inside each other. Or I can make the arm spacing much, much larger, which allows you to have the arms look like this. It looks like he's holding a box or a chair or something like that. So again, I'll put it at 50%. There are a lot more options depending on the animation you pick. So for example, I can click on this animation, has the same options, click on this animation. So most of these have the same. Let me go back to the first one. You'll see, for example, this animation has more dials to control. So for example, the target height, you can control that. How far he goes down, right? How far he goes down, how far he goes up with his legs. Hit intensity, you can increase that, like so. If you lower it all the way, you don't get hit as much, like so. And overdrive and arm spacing we already talked about. Finally, the trim part is you can trim part of the animation. So for example, if you don't want this part, you can trim all the way to over here, for example, and you only get this part of the animation. Or you could go a little bit back, and you will get this part. So this is really cool where you can trim part of the animation. You only can get certain part of it. You can get that if you want, really. Or this, which is pretty cool. All right, so what I'm going to do is select an animation. I can search here. I can say walk. And select the walk animation. So I can, for example, apply this animation on him. Like so. Looks like he's sneaking. Or it looks like that. There's a specific walk animation for him. So mutant walking. It looks much better. So I'm gonna select that animation and I'm gonna click on download. I'm going to leave everything in place. Before I click on download, I want to talk about those two options. If you click on mirror, what that essentially does is that it's going to mirror the animation from one side to the other. I'll click on it. It's not very noticeable. It's more noticeable if you select a different animation. So for example, if I click on mirror, you'll see that he's now holding his right arm. If I turn off mirror, he'll be holding his left arm. So you can switch which animation you want. And if you click on in place, what that will do is it'll make him walk in place. And so those are a few things you can control also. I'm going to click on walking, mutant walking, click on download. Now there are a few options to download with. There's FBX binary, FBX ASCII, FBX for Unity, and so on and so forth. For us specifically, we're going to select the FBX for Unity since we're using the Unity game engine. If you're using a different game engine or the Unreal engine, you can just go FBX binary. That should be fine. I'm going to select the option with skin. So what this allows you to do is download the actual 3D model with its animation, with its actual textures and skin. So we're only going to do that only for the first 3D model. The other 3D models will download only the animation. So I'm going to click on download. And that will take a few seconds to download. While it's downloading, let's look for more animation, like the idle animation. So this one looks pretty good. Just standing still while reading. You can see his arms are a little bit too tight, so I might increase the arm spacing 75%. Something like this. Looks pretty good. Body type, Not sure what body type does. Let's explore. I have no idea what that did. I assume it did something. I assume it's important. We'll keep it at 0 for now. Alright, so this is pretty good. It's pretty good animation. Actually, I might lower the arm spacing just a little bit, maybe 70. And that looks pretty good. So I'm going to, again, click on download. However, this time, I'm going to download without the skin. Make sure it's FBX for Unity and click on download. If you download with the skin every single time, that file size will be really, really big. And it's unnecessary because you already have the skin. So I'll show you an example. If I go to my downloads, and if I look at the file size for my walking animation with skin, it's 16 MB. However, the animation for idle without any skin, it's only 632 KB. So you can see there's a massive difference between the two. And we really don't need that skin over and over and over. So what I'm going to do in Unity, I'm going to create a new folder, call it enemy. Inside my enemy folder, I'm going to create another folder called 3D, or I'm going to call it models. You can open that up. And all I'm going to do simply is drag both of these inside here. And so that will import both of these. Now the next thing I want to do is make another folder called textures inside the enemy folder. And I'm going to create another folder called Prefabs. And I think that's about it for now. If I open the models folder and I click on my walking animation, you'll notice that there are no textures, or he doesn't look the way he looked in the website. If I look at the difference, you can see how he looks now and how he looks in the engine. The reason he looks like this is because we never extracted the textures and the materials. And remember, a texture is essentially what you see. You see all the detail that's in the model. That is the texture. So we need to extract that. So you can click on the 3D model itself, go to material, and click on extract textures. It will ask you where would you like to extract your textures. I'll select my textures folder that I created inside the enemy. Click on select folder. And that it will prompt you with a window that says fix now. So this is for your normal map. We'll talk about normal maps later on, but essentially normal maps allow you to have a little bit more detail in the model and a little bit bumpiness to the model. So if I click on fix now, I'll resolve that. And you can see here our 3D model with all of its textures. If I go to my textures folder, you can see this is the normal map texture, and this is our albedo texture, or our base color texture, which is applied on the 3D model itself. So you can think of this texture as it's wrapped around the model. Right. Now the next thing I want to do is go to rig, and for the animation type, I would like to select the humanoid animation. And essentially what that does is it tells the engine that this is an actual human or an animal. And so it means it has legs and it can move in the world. So I'm going to select the humanoid. And I'm going to click on apply. Now, as you can see here, sometimes whenever you do this, you're going to face some errors like so. And so the reason those errors are happening is because the rig is not importing all the bones in the 3D model, or it didn't assign all the bones. So what does that mean really? Well, if you go to configure, and if I go to my mutant, you will see that all the red, right, and the green kind of these are called bones. And just like how humans have bones, in animation we also have bones. Now, whenever you rig the model, whenever you prepare the model for animation, you need to add these bones to the 3D model so it can animate. So each single bone controls the movement of that specific object. So for example, this bone will control the arm. This bone will control the shoulder. This bone will control his finger, his thumb, and index finger, and so on and so forth. And you can see this bone will control his neck. So the issue right now, you can see that, first of all, it says character is not in TPose. This is really crucial that all the characters should be in TPose. Now, the reason he's not in TPose is because see on the right side, you can see we're missing a bone that's not assigned to the mutant. And the reason we're missing that bone is because if you notice here, on his left arm, he doesn't have any fingers, right? He just has his kind of hook or whatever that is. So what we can do is we can go ahead and assign that manually. Unity has already assigned all of these bones, but however, it's missing the hand bone, right? And if I look at the left side, in the hierarchy window, these are all the game objects that contains all of our bones for our character. So really the only bone that we're missing right now is the left arm hand bone. All the other bones are assigned correctly. What we could do is we go to left and look for that bone. So this is the hips, left leg, this is the foot, right leg, spine, left shoulder, and here you go. You have left arm and left hand. As you can see, the one we're missing is left arm, hand. So what I can do is just click on the left hand, drag it, click and hold, and drag it into this area, and that would assign it. You'll see it's been assigned over here. So I'll do this one more time while not zoomed in. If I click on the notice kind of this area, I click on, drag it over here, you'll see it kind of made this circle over here, and that's now it's assigned. And this is no longer red, it is green. Now, once we do that, it is really important for your characters to be in TPose in order for the animation to work correctly. That is crucial. So what you should do is in pose here at the bottom, select in enforce TPose. So what that will do is enforce him to go into TPose. Now, sometimes this doesn't happen when you click it for the first time. So you should click it again, click again, just to make sure this actually is working perfectly. So now he's in TPose. All you have to do is click apply and none. So we no longer have this error anymore. And so now our character is fully prepared to actually be dropped in the world and animate. So what I can do is simply drag this 3D model into the world, and you can see he is over here with all of his textures. Now, one thing that I usually do is right now, the actual game object is linked to the 3D model. And you can see that if you notice the box is both blue and it has this stripe on it, right? And so this is not an actual prefab. Whenever you see the stripe like this is not a prefab. However, it is linked to the 3D model. So what I want to do is make it a prefab. So just make it as a habit as make everything really a prefab. So I'm going to click on the 3D model, right click on him, go to prefab and unpack completely. And what that does, essentially, it breaks the link between the actual game object and the 3D model. Once we break the link, we'll drag this. Let me rename it first. I'll call it simply mutant. I'll drag my mutant into this area, and now he is prefabbed. You can see now it's just a full blue box without the black stripe that was on the top before. So now I have my object is prefabbed, which is good. Now, if I simply press play, you'll see that he will not animate. In fact, he will not do anything. The reason for that is we never assigned an animation controller. An animation controller essentially allows you to switch between different animations and allows you to play certain animations. So what I'm going to do is create an animation controller. I'm going to create a new folder, call it animation. Inside my folder, I'm going to right click, create, and I'm going to create an animation controller. I'm going to call this mutant. I'm going to open my animation controller, double click on it. I can zoom in, zoom out, and I can move in the world by pressing the Alt button and left clicking in the world. So if you click and hold Alt, you can move and you can drag things around. So this is my animation controller window. Essentially, like I said, an animation controller allows you to have multiple different animations and switch between those animations seamlessly. So you could have the idle animation, you can have the walk, the run animation, you can switch between them at will. Right now, we don't have any animation set up. So what I want to do is simply drag the 3D model, which has the walk animation, and place it over here. And when you do that, you'll notice that now we have a mutant walking node. It's connected to an enter node. So essentially what this means is as soon as we start the game, we're going to enter our animation. And the first animation we're going to execute is the mutant walking animation. So this is set up for now. If I click on my mutant, I can drag the animation controller to my animation component or animator component. So our animator component requires a controller, and I just drag the controller into this area. So I'll do it a little bit one more time. Drag the mutant controller over here. Now we'll see whenever we did this, the controller word became bolded, and you can see that a blue line appeared on the left. Now what this means is that this current change is only applied to this game object. It has not been applied to the prefab. So in order for us to apply it to the prefab, what we need to do is you'll see there's an override button here. If you click on the override button, you can click on apply all. And so what that will do is it will apply this change to the prefab file itself, which we created over here. And this will no longer be bold. So now if I go to my scene window and press play, you will see that the animation is going to simply play, like so. I'm going to stop the game, press play again. You can see the animation is playing. Now it only plays the animation for a small part. The reason for this is that we never told the animation to loop. Right now it just plays the animation, it stops, and it's over. But we want to tell it to loop. The way you do that is you click on the 3D model, click on models, go to animation, make this window a little bit smaller, and you can see here it says loop time. If you click on loop time and scroll all the way down to click on apply, that will essentially loop the animation for us. So now if I press play, you'll see he is going to walk in a loop forever, which is cool. How about we add 2 animations into our model? So what I can do is go to the models folder, and now this is the model that doesn't have any animation. And you can see previously you could see the animation before. So if I click on the walk animation and I press play, you can see he's walking, can play the animation, see how the animation looks. However, for the idle animation, you won't be able to see that because it says here, no model is available for preview. Now you can assign a model manually in Unity. If I click here, at the top right, click on Unity model, you can specify the Unity already gives you a model that looks like this, right? However, you can also pick a model yourself. So I'm going to select the mutant model. You can see here's the mutant model. You can see there's no animation is playing, nothing's happening, and he's kind of in the floor. Why is that? Well, remember, we never really set up the rig. It is important for every single model you import is you set up the rig to animation type of humanoid and make sure all the bones are being selected correctly. So for our idle animation, we never really did that. So we're going to click on humanoid. And one thing we're going to change this time is the avatar definition. Rather than saying create from this model, we're going to copy from another avatar. Now, what does this do? Essentially, an avatar is your 3D model, right? It has all the bones, it has your rig. It essentially looks like this. This is essentially your avatar with all of your bones, right? Now, we already have an avatar. We already created an avatar from the walking animation. So you shouldn't really create multiple avatars because all the animations should follow one avatar. If you have multiple avatars, what that will do is it will create a problem for you later on with your animation. Your animations might look weird, your bones might look like they're broken. You'll just see weird stuff in the animation. So only the first 3D model should create the avatar definition you should create from this model. So only one of them. However, the animations following the animations you download following that should only use that existing avatar. So for example, our mutant is going to have an idle animation, can have walk animation, attack animation, die animation, and so on and so forth. All of these animations should use a single avatar, which is the mutant avatar. If you import another model, for example, like a spider, you should create an avatar for the spider, and all the animations for that spider should use that avatar. So every 3D model will have its own avatar, one avatar, and all the animations for that 3D model should use that avatar. In our case, we have our mutant. We already have an avatar. We created one in the walk animation. So any subsequent animations we use should copy the avatar from the walk animation. Now, once you select the copy from other avatar clip, what you could do is expand the walk animation, and you will see we have an avatar over here. And this is our avatar. We can simply drag this. We can simply drag this avatar in here. And so you will see that our idle animation is using the mutant walk avatar. Then click apply, and that should be good to go. All right, once we set that up, what I can do is I can import this animation. Before I import the animation, let's actually see how it looks. So I'm going to go to animation. So I'm going to go to animation and press play. And you will see how he's idling. Now remember, the idle animation doesn't have a skin. We use the skin from the walk animation to preview this. You can either use this, or you could use the Unity model, which looks something like this. In our case, we'll just select the mutant avatar, and you can see the animation. Now, make sure you loop the animation. The way you do that is in the animation tab. You click on loop tab, on apply. We really don't have to extract the materials or textures for the idle. Remember, because it doesn't have a skin. So the only thing we really need to do is modify the rig and loop our animation. Once that is done, I'll simply drag this. I'll drag the idle animation into this area. Now you will see that the idle animation is not connected to anything, and it has a gray color. Whenever it has a gray color like this, that essentially means that it's not used. So what I can do is I can set this node as the starting node. So if I right click here, set as default state, as layers default state. And that essentially what it does is when you start the animation, this is the first animation it's going to play. Next, I want to make a transition between idle and walking. The way I do that is right click on idle, click on make transition, and select the mutant walking. Now I have a transition between enter to idle to walking. So let's see how that looks. If I go to my scene and look at my character, and I press play, you will see that he is going to play his idle animation. And as soon as the idle animation is done, he's going to transition to walking. And as you can see, now he's going to start walking forever. And you can kind of see that if I move my scene window a bit to the right like this. Click on my mutant, press play. You will see and notice here that the idle animation is playing, and this is the progress bar for the idle animation. You can see it's idling. Once it's done, it's going to transition to the walking animation. You can see the walking animation is looping over and over and over, like so. All right, so we've set up two animations, which is great. Now, what we could do is we can download some more animations, like the running animation and the attack animation and the dying animation. So I'm going to go here, type dying. Make sure you download it without skin. Download. While this is downloading, download the attack animation. There are a few. There's this jump attack. And there's this swing attack. We'll go with this one. So download without skin. And finally, we'll do the run animation. We can slow down the animation because he's running way too fast. He's supposed to be a giant. That looks just slow motion. Maybe this one. If we increase the character arm spacing. No, there's already a mutant run, so we can select that instead. Looks much better. So we can download that, also without skin. Finally, import all these animations. So the ones that I'm going to import is run, swiping, getting smashed. We'll take all these and import them inside Unity. And we'll do the same for all of them. We'll click on 3D model, make sure the rig is set to humanoid, and select the copy from other avatar. Select the avatar. You can click on the circle window and select the avatar you want. Click apply. Click on the other animation, humanoid, copy from other avatar. Select this one, humanoid, copy. Click apply. And now pretty much all of our animations are done. For swing animation, we don't want to loop our animation, so that should be fine. For our run animation, that should be looped. Should loop that. Our dying animation also shouldn't be looped. And our breathing idle is looped, which is fine. I can now import all these animations one by one. And here. I can connect all of them one by one. So I can connect walking to running, running to swiping, and swiping to dying, like so. So now if I press play, you'll see that he's playing his idle animation. And then he's going to start walking, and then start running, and then swipe, and then finally die. right? And he stopped at dying because we never looked at. Cool. So we have all of our animations set up. Now, what we can do is control these animations rather than playing them one after the other. We can control all of them in a script. So we can tell the C# script how to behave and how to kind of play one animation when it's appropriate. We'll do that right now. So what I'm going to do next is go to the enemies folder, create a new folder called scripts. And essentially a script is a bunch of code that tells the computer what to do or tells your game object what to do. And so what I'm going to do is create an enemy script. So right click, create a C# script and call it enemy. Now, once you do that, double click on it, and that should open Visual Studio 2022. Now, Visual Studio 2022 will look something like this. However, you might, as someone who just installed Unity for the first time, you might face some issues. One of these issues is, well, one of the features of Visual Studio is called IntelliSense, and IntelliSense essentially helps you autocomplete. It's like have you in your phone autocomplete feature in Visual Studio you have the same thing. So once you start typing anything, you can see you have a drop-down menu of all the type of things that you can select and do. Now this might not be working perfectly for you. So for example, if I type transform as a component, you can see that transform pops up. If you type transform and transform doesn't pop up, then IntelliSense is not communicating with Unity very well or at all. The other way you can find this out is that if you hover over the word monobehavior, you can see there's a drop-down box with a description of what monobehavior is. You can see that monobehavior is green. However, if IntelliSense is not working with Unity, then this word will be white, and when you hover over it, nothing will happen. And I'll show you that example real quick. So if I go to preferences, go to external tools and select file by extension. You don't have to do this on your end. I'm just showing you an example of when it's not working. And then I'll show you how to fix it. If I double click and open the file now and select Visual Studio 2022, you'll see now that we have that problem. You can see that monobehavior is white, and if I hover over monobehavior, nothing happens. If I type the word transform, you'll see that the menu is too small and it doesn't have transform. Now, how do we fix this? How do we communicate or allow Unity or Visual Studio to communicate with Unity? The way we do that is by going to Edit, Preferences, go to External Tools, and from there, click on the External Script Editor and select Visual Studio 2022 or 2019 or 2017, whichever one you want to use. Once that is done, Unity will take a little bit of time, and then make sure to create on regenerate project files. And in theory, Unity should be able to communicate well with Visual Studio. So if I open my script again, you will see that we don't have that problem anymore. Give it a second, you can see it's all working. If I type transform, you can see my transform exists. All right, so we solved that problem. One other beginner issue that you might face is that, let's say, you go ahead and create a script. Right, so I'm going to create another script for now as an example. Right click, create C# script. You can see it's giving you the option to rename the script, right? And the name by default it gives is new behavior script. If I click somewhere by mistake, the script will be called a new behavior script. Now, obviously that's not the name that I want. And so what I do is simply go right click, rename. I'm going to call it Dragon. So I renamed my script. No harm is done. When I open my script again, and go to Unity, if you clear all these warnings, and attach this dragon script to a game object, you'll see Unity either is going to crash or is going to give you an error. So let me open up Unity again. Now, the reason this happened, the reason Unity crashed, is because it is really important for the script name to have the same name as the class name. So if you look here, this is our script, this is our code, and there's something called a class. We'll talk about that in a second. Essentially, the class has a name which is new behavior script. Now remember, when we misclicked on the screen and the script was named new behavior script, we renamed it to Dragon. However, when we renamed it to Dragon, the class name didn't change to Dragon. So we have to do that manually. And so if I go to Unity, and if I try to attach it again, it's going to crash. So let's not do that. So I'm going to rename this to Dragon. Then same exact name should be applied for the class name and the script name. And make sure the capitalization is also correct. So small d Dragon and capital D Dragon are not the same thing. So make sure it's exactly the same. And now you can go to Unity and attach this game object, or attach the script as a component, like so, and it should work just fine. So I'm going to remove it for now, and I'm going to delete my Dragon script. So this is just something to look out for, right? It's really important. It's a very common mistake, and it happens a lot. Just make sure that the script name is always the same as the class name. Now, there are some rules for naming scripts. For example, you cannot start a script with letters. So you cannot call a script, you cannot name a script with a number. So for example, you cannot call a script 12 enemy or 1 enemy. You cannot start a name with a number. You can put the number later on, so you can call it enemy 1 or enemy 12, right? However, you cannot start it with a number. You cannot put spaces anywhere at all. You cannot call it enemy space 12, so there should be no spaces. And you cannot have any symbols. You cannot have question mark, exclamation point, an ampersand, right? You cannot have any of these symbols. However, you're allowed to have an underscore. So you can put an underscore anywhere you want, in the beginning, in the middle, in the end. It doesn't matter where you put it. So those are the rules of naming a script. You cannot start with a number, you cannot have spaces, or you cannot have symbols. You can have underscore anywhere you want, you can have the numbers anywhere you want, but the start of the name. All right, so I'll make sure that the script name and the class name matches. Again, that's really important. And so now we can start programming, and I can introduce you to C#. Now, C# itself is a human readable language. As you can see, it's English-like. In fact, it is English. I can see there are words like public, class, monobehavior, start, void, update, and so on and so forth. Now, what I want to start with is the green lines, right? Because it's kind of the first thing that you see, and they pop up a little bit. So the green lines are called comments. And a comment essentially is a way for programmers to communicate with other programmers, or for programmers to write reminders for themselves, or a way to explain the code for themselves. Because if you write some code 2 months or 3 months or a year down the line, you're not going to remember what this code kind of did. And so you can put 2 forward slashes, and you can write whatever you want. So you can say, this is the start function. And so the computer will completely ignore this line. It will not work with it. It doesn't mean anything to it. It will in fact remove it when you run the application. But this is just for us to remember the script, what the script does essentially. For now, I'm going to remove these comments, and my script kind of looks like this. So what I want to start with is explain the start function, and this is called a function. A function essentially is a block of code that gets executed by the computer. Now this function will only run once at the very beginning of the game. That's why it's called the start function. So this function will only run once. Now there's also the update function, and the update function is also a function that gets executed by the computer. So if there's code inside the function, it will be executed. This function will run once per frame. Now you might not know the concept of a frame. Essentially, whenever you play video games, you might have heard 30 frames per second or 60 frames per second. Essentially, our jobs as game programmers or game developers is to draw every image, or tell the computer how to draw every single image. So I'll give you an example. If I go to YouTube and check out this video, what this person is doing, he is rendering or he's drawing every single frame manually, and he's flipping the book. And what that does is you'll perceive motion by him doing that, right? And so this is what we essentially do as game developer. We draw or we render every single frame, or we tell the computer how to render every single frame. And once we display all the frames, if we display 60 frames per second, that will give us the perception of motion. And so this is what the update function does. And the update function doesn't render. The update function runs once per frame. So if we're running at 60 frames per second, that means this update function will run 60 times in 1 second. And essentially what we put in the update function are logic. We add logic like move an enemy from one location to the other, or check if the player has pressed a key on his keyboard, or if he moved his mouse, or if he fired his gun. And when he fires his gun, move the bullets, right? So all this happens in update. And so update runs once per frame, or 60 frames per second if you're running at 60 frames per second. Start, however, only runs once at the very beginning of the game. And start is useful for things like spawn the enemies at the very beginning of the level, or set up the level, or connect to a server at the very start of the game, and things like that. So those are the two functions that come by default from Unity. Now you can see that those functions exist inside something called a class. And remember, if we go back to Unity, how Unity Engine works, we said that the Unity Engine has game objects. An object is just a container for components. So a game object just holds components. A class works the same way. A class on its own is useless. A class is the same thing as a game object, or in terms of the analogy we're taking over here. So a class is just a box, just like a game object, it's just a box that holds components. So a game object holds components. A class holds functions. Functions, they define the logic and they define what this class is doing. A class is just a container. And so right now, we just have two functions, an update and a start function. And both of these functions exist inside the class. And so right now, our class is called the enemy class. And it's inheriting from one behavior. Inheritance, essentially what it means is all the properties or all the functions or all the functionality and variables, essentially whatever inside mono behavior will also be inside enemy. So inheritance is the concept of I'm going to take functionality from a different class, and so what this class has, I will also have. So these two functions, they actually come from mono behavior. So the start and update function, they come from mono behavior. And because we're inheriting from mono behavior, we get those functionality. So for example, you could have an animal class. An animal can walk, can move, can eat, and has a bunch of functionality. Now, you can inherit from an animal. So for example, a dog can inherit from an animal class, and the dog can bark. A cat can also inherit from an animal class, but the cat can meow, right? So the animal class has the base functionality of what this class does, and different animals can inherit from it and take that functionality. And so the same exact thing is happening over here. Now don't worry about this too much. We'll talk about inheritance way later on. For now, just to give you an idea of what the colon means when we do a colon and say mono behavior. So all the functionality inside mono behavior also exists inside the enemy class. Now this class is marked as public. Public keyword just essentially means this class can be used by other classes, or it's exposed to other classes. Don't worry about it too much. We'll talk about it later on. Now, the really important thing that I want to talk about and highlight is something called a scope. A scope essentially is the starting point and the end point of something. So for example, the enemy class has a starting point at line 6 and it dies or it ends at line 16. You can see those are called curly braces. So this is an opening curly brace and this is a closing curly brace. You can see that there's a dotted line between those two curly braces. Anything inside those two curly braces belongs to the enemy scope. And so the scope of my enemy class starts at line 6 and goes all the way to line 16. So you can think of a scope as a starting point and an ending point essentially. Our start function also has a scope. Our start function scope starts at line 8 and ends at line 11. So anything written in here belongs to the start function. Same thing for update. Update also has a scope. It starts at line 14 and 16 because of those curly braces. And so anything inside this belongs to the update function. So those are scopes, and they're really, really important because essentially they allow us to figure out when things start and when they end. And they allow us to figure out where to put our code in. And so this is really important. Now, finally, before we start writing some code, I want to explain the top part where it says using system collection or using system collection generic and so on and so forth. Those are called namespaces. Namespaces essentially are ways for us to organize our code. So to give you an example, if you go to a library and you see two books, one is called Harry Potter and Chamber of Secrets, written by J.K. Rowling. Another book called Harry Potter and the Chamber of Secrets, written by me, because apparently copyright law doesn't exist. So two books, they have the same exact title, but written by completely different authors. If you go to the librarian and tell her, I would like the Harry Potter book and Chamber of Secrets, how would she know which book do you mean? Do you mean the book written by J.K. Rowling or the book written by me? Well, you can tell her the author name, right? And so those are exactly what namespaces are. The namespaces is another way to organize our code to figure out what are we talking about. In terms of programming, you can have a class called enemy. That class is written by me. And you can have another class called also enemy, written by someone else. How would you differentiate which enemy I'm talking about? Well, you can differentiate it using the namespace. So you can encapsulate, or you can put the namespace for an enemy. Namespace called Mustafa and namespace called David. So if you say Mustafa's enemy, you're talking about that class. If you're talking about David's enemy, that class. So in here, we're just importing or using some namespaces in the C# language. So you can see here, we're using the system namespace. Inside it, there's the collection namespace. Here's system collection. Inside it, there's generic namespace. And we're using the Unity engine namespace. The dot operator, or you can see the dot here, what that means is inside the system, I would like to access collection. So the dot operator allows you to access things inside other things. So I'm accessing the collections namespace inside the system namespace. The way I do that by typing dot. Same thing for generic. I'm accessing generic inside collections. The way I do that is by tapping the dot operator, like so. All right, so that's essentially is our entire program from start to finish. Now, in order for us to actually run the program, what we have to do is attach it as a component. So scripts can be attached as components for game objects. But what I'm going to do is drag the enemy script to the mutant game object. And you can see it's attached as the game object. Once again, you'll see that there's this blue line here. This blue line means that this change was only applied to this game object, and it was not applied to the prefab. So remember to go to override, and when you go to override, you can see what changed. And what we did is we just added the script. So if I click on apply all, you'll see the blue line will disappear, like so. So now this change is applied to the prefab itself. Right. So we've attached the script, our enemy script, as a component of the mutant game object. If I press play, nothing will happen because the script right now does nothing. So what we can do, we can print something in the console. So in start, what I can do is I can type print hello world, I am the mutant. I'll explain this line of code in a second, but if I go to Unity and press play, you'll see in the console, you'll say, hello world, I am the mutant. And this appeared because we put it in start and we put it inside, we attached the enemy script to the mutant. If you don't see the message, it might be that you forgot to attach the script as a component. So you can see the script is no longer attached and nothing happens. In order for scripts to run, you have to attach them as components. So I'll just drag it over here and attach it. You can remove a script from a game object by right-clicking on it and selecting remove component. You should not have two of the same script attached to the same game object. This just means that the script is now running twice. It's kind of useless. So I'll make sure to only have one version of it. Again, click on overrides and click apply to apply our changes. So now there's one script attached to our mutant game object. This script is attached as a component and it will run whatever is in the start function and whatever is in the update function. Press play one more time. You should see the message pop up like so. All right, so let me explain this line of code. Essentially, print is a function. This function is also written by Unity and it's inside monoBehavior. And even if I hover over print, you'll see that it says monoBehavior.print. And remember, the dot operator allows us to access things inside other things. So print is inside monoBehavior. So to access print, we do monoBehavior.print. However, because we're inheriting from monoBehavior, we don't need to do that. So we just type print. Anyways, so we have the print. This is a print function. How do I know it's a function? It has brackets. Essentially for now, you can think about this for now, that anything with brackets is a function. That's not completely true for now. There are other things that has brackets that are not functions. But for simplicity's sake, whenever you see brackets, just know it's a function. So our start function has two brackets, our update function has two brackets, our print function has two brackets. Now this function takes an input. So functions, essentially, they can take an input and they can give you an output. Imagine it as an apple cutting machine. So you can have a machine, you can give it an apple, that apple will be sliced into the machine and give you an output of a sliced apple. So a function works exactly the same way. It takes an input, gives you an output. The function will process that input, do something to it, and give you an output, just like the apple. So in our case, this print function takes an input of a message, and this is our input. The output is it's actually outputting this message in the console. So this is essentially what the print function does. It takes an input, and that input will be outputted in the console. Now the input it takes, it can be anything. In our case, the input is a string. A string is just a collection of characters. You can see the string has double quotes. So anything that has a double quote is a string. So it has a starting double quote, has ending double quote. And this entire thing is just a string. Now, if we forget to put the double quotes, the computer will try to understand or make sense of this. It might think that hello is a class or world is a function. And obviously, we don't have hello as a class or a function. There's nothing called world as a class or a function. So this is invalid code. However, when we put the double quotes, we're basically telling the computer, hey, this is a string, just a collection of characters. You can send that to the print function so it will be printed on the screen. So it's really important whenever you're dealing with strings or whenever you want to print something on the screen, you put double quotes. You surround the sentence with double quotes, like so. Finally, we have the semicolon. And the semicolon essentially means, hey, this is the end of my statement. This is a statement, and this is the end of it. That's the entire line of code. And again, if I go press play, you will see it says hello world. I am muted. What I'm going to do next is, if I press a button, I would like a certain animation to play for the muted. So I can create an if statement. In this if statement, I'll say input dot get key, and the key code is space. So what this line says, if I press the space key, I should do something. And this is an if statement. An if statement allows you to execute some code if the statement is true or false. So if this is true or false, it will go ahead and execute the code. If it's true, it'll execute the code. If it's false, it will not execute the code. In this case, we're accessing the input class. Inside the input class, there's a getKey function. Inside there, if I press space, I do something. In my case, I'm just going to put a simple print statement again. It says hello. And so I'm doing this in update, and I have to do it in update because remember, we need to check if I pressed a key every single frame. If I just do it in start, it will only check if I press the key at the very first frame of the game. Subsequent frames, it will not check for any key press, which is an issue. So we should always check for key presses in update. Anything really that should happen every frame should be in update. So every frame we're checking, did I press space? Did I press space? Did I press space? If I do press space, I print hello. If not, I didn't do anything. So if I go here and press play, and I press space, you can see multiple hellos showed up. If I press and hold, it's gonna print hello over and over and over. Now, one thing that's really important is that whenever you want to test something, make sure you always click at least once in the game window. For example, if I click in the hierarchy window and I press space, nothing will happen. You need to make sure you click in the game window and then press space. Next up, what I want to do is access the animation component or the animator component and change the animation or specify the animation that I want to play right now. Now, to access a component from a script, it's simply you type serialized field at the very top here, and you type animator, and I'm going to call this animator. So what am I doing here? Well, I'm creating a variable, or I'm creating an object. The variable name is called animator. You can call this whatever you want. You can call it haha if you really want to. In my case, I'm calling it animator, small a. The type of this object is animator, capital A. So whenever you create objects and variables, you have to give them a type, right? Whether it's an integer, whether it's a string, whether it's a boolean, you have to give your variables a type. So after I created my variable or object, which is called animator, I am adding this extra thing. It's called serialized field. And serialized field, essentially what it does is it exposes the variable inside of Unity. So you'll see that in the inspector, now I have a variable called animator. And so what I can do is I can drag this animator component inside of here. So essentially what I've done is I've linked both the animator component to my script. So as you can see here, what I've essentially done is I have linked this animator component into my script, which has a variable called animator. So the variable animator and the component animator, I've linked them together so I can use this variable. If this variable is called haha, it would be the same thing. It doesn't really matter. The names don't have to match. You'll see that says haha. So I can link the animator to my haha variable, which is also a type animator. So the type has to match. So the type animator over here has to match with the component name, which is animator. And so, but the name, what you call it, doesn't really matter. So now both the animator component and the variable are connected together, which means I can now access this component and use this component and manipulate this component. I'm going to go back to calling it animator and make sure that I reference it. This is called referencing, which is already referenced. So now I can go ahead and write some code and access the animator. And so before I write some code, I need to set up my animator. If I go to my animator, open the animator controller, what I can do is I can go to the section that says parameter. So in my animator window, go to parameters, and in here, I am going to click on the plus sign and click and select the bool and name this to walk. Gonna make another bool, call it run. Gonna make another bool, call it attack. And finally, the last bool, die. So essentially, I've created 4 variables inside of my animator controller. A variable called walk, a variable called run, a variable called attack, and a variable called die. All right, so what I've done here is I've deleted all the transitions from all the animations just to make sure to do this properly from the start. So what I want to do is I would like to create a transition from idle to walking. And the condition, you can click on the arrow to set a condition when should you move to walking. And so the condition that I'm going to say is when the variable walking is true, you can transition from idle to walking. I'm going to make another transition from walking to idle, and I'm going to say you can only transition from walking to idle when walking is false. And same thing for swiping. I can attack while I'm idle, and I can attack while walking. So I have transitions for both. And I can say you should only transition from idle to swiping when attack is true, and same thing from walking to swiping when attack is true. You should go back to walking when attack is false, or when walk is true. So if we make walk is true and attack is false, we can have 2 conditions. Then you can go back to walking, and in here we can make a transition that says when attack is false, you can go back to idle. So both attack should be false and walk should be true to transition back to walking. And this just simply says when attack is false. As for run, you can run if you're walking, and you can go back to walking if you're running. So you can transition from walk to run if run is true, and you can go back from run to walking if run is false. As for dying, you can die in any state. So you can die if you're idle, you can die if you're walking, you can die if you're running, and you can die if you are still attacking. So we can organize this a little bit more, like this. And so if die is true, you go here. If die is true, you go here. If you die is true, you go to die. And finally, if die is true, you die. Now there's no going back from dying because once you die, you die. All right. So in theory, we can simulate this and we can test this real quick. If I go to my scene and if I look at my animation, you can see that he's just idling. And so if I make die is true, Give it a few seconds. He needs to finish his idle animation before he dies. So give that a few seconds. So now he goes and dies. So he transitioned immediately to dying. He didn't have to go through any of these, right? If I turn off die, nothing happens, right? Now you notice that he only died after the animation is done. And that's not great. Sometimes we want him to die immediately. And so the way we can do that is there's something called has exit time. So when you click on one of the arrows, it says has exit time. What that essentially means is if it's on, you're saying you should finish the animation before you transition. If it's off, you cut the animation and you just transition immediately. And so that's what we want to do. We want to transition immediately from all these states. So turn off all of them for all the errors. Now, for attacking, for swiping, you should finish swiping before you move to anything else. So that's kind of important. So you shouldn't transition to walking before you finish swiping. And same thing, for dying, you can transition, that's fine. And so now we can test this. If I go to walk, he starts walking immediately, and then I can stop him. And if I press run, nothing happens. He has to be running. He has to be walking before he starts running. And so that's important, right? I would like to transition that immediately. So from walking to run, he should transition immediately, and he should transition immediately here. Let's try this one more time. So walking is true. Run is true. He's running. I turn it off. He stops, right? And then I can do attack. So I can attack immediately. Attacking is not looped. So what we need to do is loop attacking. We forgot to do that. So you can click on the 3D model itself and say loop time, apply. And so now we can attack immediately, even for idle. You can see he's attacking. We can attack if we're walking, he should be attacked. If we're running, he should be able to attack. Ooh, we don't have a transition from running to attack. So that's something we need to do. So if he was running, he should also be able to. So if attack is true, he should be able to transition immediately. Let's make him run, walk, run, and then attack. He attacks immediately, and then he can attack again. If I turn off attack, he should go back to running. And if he dies, he just dies. Right? So this is all good. We have all these transitions. We've set up our animation controller. And you just really need to think about what do you want to do in each single animation state. All right, so once this is set up, once we have all that is working, what I can do now is controlled in the script. So in the script, what I want to do is say, if I press space, then the animator, I have a function called setBool, and the Boolean takes two parameters. The first parameter is the ID of the variable. My case is walk. So I'm going to type walk. The name has to match exactly like how we typed it in Unity. And then we can set it to true. So now if I press space, then walk will become true. And if I go and press space, move this window over. If I press space, he should be able to walk. You can see he is walking. So I've controlled that from the script itself. And you can control any of these variables by calling this function. So set Boolean, the variable name to true or false. What I want to do now, before I move on with writing more logic for the enemy, I would like to set up my player. So this was a good introduction for the animation. Now we want to set up our player. So I'm going to create a new folder for our player. And I'm going to create a scripts folder. And in here, I'm going to create a new script called player. Now for now, I'm going to represent my player as a capsule. Now, usually you would actually download the animation and the appropriate model, but you can do that on your own, seeing that you know how the process goes. So I'm going to create a 3D model, a capsule. reset the transform to 0, 0, 0. This is my capsule. I'm going to rename my capsule to player. And I'm going to attach my player script to the capsule. Next up, what I want to do is just add a simple cube, like a nose, so I can know which direction this capsule is facing. So I can put that at the very top here. Right. I'll give it a different material color to differentiate it a little bit easier. Go with green. And we'll give the player a red material. Okay, so I'm going to move the music a little bit behind, and essentially this is my player. So my objective now is to be able to move in the game using my player. Now to do that, I have to edit my player script and write the following code. So we'll start with WASD. So I'm going to say if input.getKeyDown or getKey W, and I'm going to replicate this 4 times. So WSAD. Essentially, this moves forward, this moves backward, this moves to the left, and this moves to the right. So how do we move in the game? Well, whenever we move, we actually use the transform component. So I'm going to say transform dot position plus equal new vector 3. This would be, actually it's transform dot forward, multiply by a certain speed, multiply by time dot delta time. I am going to create a variable, a serialized field variable of type float, call it speed. And so this variable will control my speed. So essentially what I'm doing in this line is every frame, I'm moving the player in the forward direction and with a certain speed and multiply by time dot delta time. Time dot delta time, what allows us to do is it measures the time it takes between 2 frames. And this helps us in making the game consistent, the speed of the game consistent between all computers. So some computers are slow, some computers are fast. And essentially, if you take this game and run it on a fast computer, our movement speed will be extremely fast. If we run it on a slow computer, our movement speed will be extremely slow. When we multiply by time to delta time, what that allows us to do is make the movement speed consistent on all computers, no matter if it's fast or slow. So I'm going to duplicate essentially this line 4 times. And if I press W, I move forward. If I press back, sadly, there is no backwards. However, if you subtract, you do minus equal forward, you are going to go in the backward direction. Same thing for D. This would be right side. And there's no left. So we'll do right, but minus right. So that will allow us to move in all directions. If we go ahead and click on the player and set the speed to 10 and press play, in theory, we should be able to move in all directions. Move the music a little bit back. And so if I press W, he moves forward, S goes back, D right and left. So I can move in all directions. Next up, what I want to do is I would like to move, or I would like the player to rotate according to where my mouse is. So what I need to do for that is create a few variables. One is a float mouse X, and then another float mouse Y. And in update, I'll do mouse X plus equal input dot get axis mouse X, and same thing for mouse Y. What this function allows us to do is get the mouse delta and how much my mouse moved in since the last frame. So this will return a number between -1 and 1 of how much my mouse has moved so far. And what I'm doing is I'm adding that number into mouse X and mouse Y. And this is really cool because the more I move my mouse, the more I am adding that value into my variable. And so I can use that to figure out how much I moved in degrees since the last frame, or how much I moved in degrees in total, really. So what I can do now that I have those variables, I can do transform, rotation. I'm accessing my transform component. I'm accessing my rotation, and my rotation is a quaternion. And so what I'm going to do is convert the quaternion to an Euler angle variable, a new vector 3. And I would like to do mouse Y, mouse X, and 0. And so what I'm doing here is quaternion is a data structure in C#, which allows us to do rotations without having the issue of gimbal lock. And so if you don't know what gimbal lock is, you can Google it real quick. Essentially, when you rotate an object, you prevent locking an object or preventing two axes being pointing in the same direction. And so quaternion just helps us for rotations, to do rotations without the issue of gimbal lock. However, the problem with quaternions, they're valued between -1 and 1. And so whenever we want to rotate something, we usually say, I want to rotate by 45 degrees or rotate by 80 degrees. And so we need to convert our quaternion to an Euler. So we have an Euler function that takes how much I want to rotate in degrees. Once that Euler function takes those parameters, it will convert it to quaternion, and that quaternion will be passed into my rotation. Now, for a vector 3, it just has 3 values, x, y, and z, and these are our 3 axes. And so I want to move, I want to rotate in a certain direction or a certain degree on the x-axis, y-axis, and the z-axis. Now you might have noticed that I've set here mouse Y and mouse X. So the X, in theory, what this is supposed to be is mouse X, X for mouse X, and Y for mouse Y. Why did I flip them? Well, essentially, if you think about it, whenever I move my mouse up and down, I want to move my character right and left. So I can show you that in my player. So I would like to, again, when I move my mouse up and down, I want my player to look up and down. The rotation for up and down is the x-axis. So if I rotate on the x-axis, he looks up and down. And that's why I'm basically saying, hey, when I move my mouse up and down on mouse Y, rotate on the x-axis. Same thing for the y-axis. If I move my mouse right and left, I want to rotate on the y-axis. So he looks right and left. And so I have my mouse X, the position of my mouse X, on the Y rotation. And so in theory, after doing all that, I should be able to rotate my player right, left, up and down. So if I look right, left, up and down. Now one thing, so this works perfectly. However, you might have noticed that the up and down axes are inverted. The reason they're inverted is because Windows, the Windows operating system, has the axes inverted. So in Windows, Y is minus on the top and Y is positive on the bottom. This is Windows. However, on Unity, Y is positive up, and for the bottom, Y is negative. And so the signs are not matching. So what you can do is just multiply this by -1, and we'll invert the axis. This will be +1, this will be plus, and this will be -2 to match Unity. So I could either do that, or I could just reverse the sign. So rather than just typing mouse Y, I do minus mouse Y. And so this inversion should be fixed. When I move my mouse up, I look up, down, down, right, right, left, left. And if I move forward, I can move and go anywhere I would like. So what I want to do now is start building my level. So I'm going to right click and create a plane. Reset the plane to 0, 0, 0. Make sure the plane is around 10 by 10. And I'm going to move my player a little bit up. Like so. Now one thing I want to do, since this is a top-down game, I'm going to set the camera to look from the top. To do that, I can drag the camera a little bit up, rotate it on the x-axis, look down like so, and attach the camera as a child of the player. So now, whenever the player moves, the camera will also move with it, like so. Now, one thing I want to do is I'm going to disable the mouse Y. And the reason I wanted to show you that is because if you want to create a first-person shooter, that's how you would do that. But for now, because this is a top-down shooter, I'm not really going to look up and down. I'm just going to shoot, or I'm going to move my player right and left. So I'm going to zero this out. And I can comment this line like so. So this line will not be used anymore. And what that will allow us to do is just look right and left. And like so. So what I want to do next is be able to shoot the enemy. And the way I do that is I'm going to shoot a ray from this green cube in the forward direction. And if this ray hits any enemy, it will kill him when I click my mouse button. So we can do that easily. First, I'm going to make this a little bit longer. So this will be our indicator of where am I currently pointing, or where am I currently shooting. So I'm going to make this a little bit longer, like so. We can make it a little bit smaller, like 0.1, 0.1, and we can make this 20. So you can think of this as our laser. And you can think of it as where it is going to, anything that it hits, it's going to kill essentially. Now, the way we do this is we would like to cast array. Casting array is very simple. What we can do is type physics dot raycast, and we want to specify where would we like to cast the array. The position, the starting position, is my position. I would like to cast it in the forward direction, and the ray, the distance of the ray is mathf dot infinity So I'm looking for the correct signature that I want to use. I would like to make a ray hit called hit. What that will do is say out hit. And finally, I would like to specify my player mask, which would be player mask dot get mask called enemy. And we should put that in some sort of boolean, bool ray hit. We can put this on multiple lines, so we'll be able to see it a little bit better. Nice. So what we're doing right now, we're casting array, or we are casting, or we're spawning a line, an infinite line that goes in the forward direction, right? I'm saying that my line starts at my player position. It goes in the forward direction. If it hits something, that hit information will go out and will be saved in this variable. The ray is infinite, and it should only hit the enemies. So what I'm going to do here is I'm going to say if we hit someone, we want to check who did we hit. Or actually, when we hit someone, we know it's an enemy. So if we hit someone, what we want to do is say destroy hit dot collider dot game object. So if we hit an enemy, we want to destroy the enemy game object. And the way we get the enemy game object is by accessing this variable hit, entering his collider, and killing him from the game object. And so now what I have to do is take the mutant, change the layer from default, and name it enemy. You can see that the layer is set to enemy. Make sure it applies to everyone. And for the override, apply all. So this layer here, where it says enemy, this name has to match exactly as the layer. Because we're basically saying only check if we hit something called an enemy. And that would be in the layer. So now in theory, if we rotate the player to the enemy, he should die. And he doesn't die. So the reason he doesn't die is we never added a collider on the enemy. Essentially, a collider is, so I'm going to go to physics and add a box collider. And a box collider allows us to detect if we hit something or not. Now I'm going to change the material to black because it's a little bit hard to see what's going on right now. A little bit easier now. You can see the mutant has this box around him. We can modify this box and adjust it to him like so. So I'm gonna go to isometric perspective. So we're gonna isometric projection. So we're going to ignore the perspective. It's easier to work with. Gonna zoom a bit more. So, and we're just going to make this fit the enemy. Like so. I'm gonna turn off the skybox just so you can see it a little bit better. So if you click here on this icon, turn off the skybox, let's see, it's a little bit easier to see. Click on this area over here. A little bit fatter on this side, a little bit like on this side. Go here, this looks fine. On the top, this looks fine. And then I can go back to my perspective mode by clicking on this. So you can see there's a box collider around him. So in theory, now if I rotate, hit the enemy, he should die, like so. Perfect. Now, one issue that I currently have, I believe what's going to happen, if I press space, it should be fine. So if I rotate, and now he dies, which is kind of cool. Okay, so we're done with this part. The last part that I would like to do is delete the start function because we don't use it. Delete this variable, we're not using it. I want the enemy to chase after the player. And this is easily done. I will implement it and explain the math behind it in a second. So what I'm going to do now is make the enemy walk towards the player. So the first thing I would like to do is set the boolean of walk to true. So the enemy will start walking the second he is live. And then what I'm going to do is make the enemy look in the direction of the player. And this is easily done by typing this. So transform dot look at player dot transform dot position. And we need to make a player variable, call a player. And here I'm going to say player equal find player of type player. So now what is going to happen is that the player, first, when we start the game, the enemy is going to look for the player and find the player. And the way we do that is that it will go through the hierarchy and ask, are you the player? Are you the player? Are you the player? Once it finds the player, it will set it to the variable player. So this function essentially goes and finds the players. Now, once the player has been found, we set the animator to walk, so to make the enemy walk, and then we're gonna make it so that the player or the enemy is always looking in the direction of the player. And so now if I press play, you will see that the enemy is walking towards the player. And if I move somewhere, you can see how the enemy is chasing after the player, like so. And if I look at the player, the enemy, he dies immediately. Now the enemy is a little bit too high above the ground, so I'll just drop him a little bit, like so. If I press play, yeah, it looks fine. It's actually going a little bit up because of the player, so we'll drop the player a little bit down. One thing we want to do and change is when we look at because you've noticed here that the enemy is going to walk, it's kind of going up. And the reason it's going up is that the enemy is going to this dot over here. So you can see he's moving in the up direction. Now, when we want to look at the player, we want to say, hey, only look at the X and Z axis. So right, left, up, right, left, forward, and backward. We want to ignore the Z axis. So to do that, I'm going to say vector3 player position equal to player transform position. I'm going to say the y-axis should be equal to my y-axis. And so we can do this now. And so now the enemy will not go up, will not have that issue. He's going to walk straight. And we really need to make the enemy a little bit bigger because it's a little bit too small. So 2, 2, and 2. Maybe 3, 3, and 3. He's a little bit more scary now. Save the scene. You can see the enemy is now going towards the player, which is awesome. So now if I look at the player, or if I look at the enemy, he dies immediately. And so we can spawn a bunch of these. We can control D, a bunch of them. Right. Put one over here, one over here, one over here. And move them around in the level. They're all around. I maybe have spawned a little bit too many. But either way, if I press play, now you have a bunch of them just chasing me. That's pretty cool. And then I can just kill all of them by looking at them, which is awesome. All right, I think that is really it for the game. You can expand this game so much more by adding a spawning system, by adding a health, and so on and so forth. So feel free to expand this as much as you'd like. But that's it for the workshop. I hope you enjoyed this, and I'll see you later.